In the next illustration, that's illustration number 10, we have to check whether a given number is a part of the AP or not. So here we have to check whether minus 150 is a term of the AP 11852 etc. or not. So for that also we will be using the properties of the nth term. We have A equal to 11, and since it is given that it is an AP, the common difference would be 8 minus 11, that is equal to minus 3. Now let us assume that AN is equal to 150 is a term of the AP. So if AN is equal to 150, then 150 would be equal to A plus N minus 1D. We will be finding out if there is any possible value of N that is possible such that AN equal to 150. So now we have 150 equal to A is 11, N we have to find out, and D is minus 3. So 11 goes this side, so it becomes 139 is equal to minus 3 N minus 1, or N will be minus 139 by 3 plus 1. Now this is not divisible. 139 is not divisible by 3. So you will be getting a fractional value of N here. You will be getting a fraction. Now if N is a fraction, can nth term be a fraction? No, N has always got to be a natural number for this to be an AP. So because N is the number of terms, a number of terms cannot be a fractional value. So N has to be a natural number. But here we obtained N as a fraction. Hence we can clearly say that 150 does not belong to this particular AP, because if 150 is a part of the AP, then the N that we obtain is a fractional value, which is not possible because N always has to be a natural number. So we can state here that minus 150 is not a part of the given AP. Now in the second question, that's the 11th illustration. In the following APs, find the missing terms. So we have two terms given and we have blanks where we have to fit in the missing terms of the AP. How do we do that? If you take the first question, the first term is 5, right? The second term would be A plus D. The third term would be A plus 2D, and the fourth term would be A plus 3D. If you recall, this is how we get it, because we know that AN equal to A plus N minus 1 into D, if you recall this. So A2 would be A plus 2 minus 1 into D, A3 would be A plus 2D, you have to substitute N as 3 here, and A4 would be A plus 3D. So from here we get this. So A is 5, the second term would be this, the third term would be this, and the fourth term would be this. Now fourth term is given as 9 1 by 2. 9 1 by 2 would be 18, 19 by 2. And A is given to be 5. So 3D equal to 19 by 2 minus 5, which is 9 by 2. You cancel it out and you get D equal to 3 by 2. So the second term would be 5 plus 3 by 2, that's going to be 13 by 2, and the third term would be 5 plus 2 into 3 by 2, which is equal to 8. So we can fill these numbers as 13 by 3 and 8. This is how you do it. Let's see it through the second question, you'll be getting more clarity. The first term, A is minus 4. What will be the second term? A plus D. The third term would be A plus 2D. How many terms we have? 1, 2, 3, 4, 5, 6. So we write it up to the sixth term. The sixth term would be A plus 5D. And A plus 5D is given as 6. So from here, A is minus 4 plus 5D is equal to 6, or 5D equal to 10, therefore D equal to 2. We get D as 2. So we find out the second term would be minus 4 plus 2, that will be equal to minus 2. The third term would be minus 4 plus 2 into 2, that's 4, is equal to 0. The fourth term would be minus 4 plus 3 into 2, that's 2. This will be minus 4 plus 4 into 2 is equal to 4. So we can fill these numbers now. It will be 2, 0, 2 and 4. I hope you got it. Let's see it once again to understand it more clearly. We have to fill in the numbers of the given AP. So we know that this is an AP. We have two missing numbers. Using the general formula for nth term, we can calculate the second, third, fourth term as a plus d, where a is the first term, a3 is a plus 2d, a4 is a plus 3d, and so on and so forth. So this is how you get the nth term and the second and the third and the fourth term, etc. Now we write these. The first term is a, which is equal to 5. The second term will be a plus d. The third will be a plus 2d, and the fourth will be a plus 3d. Now it is given here that first, second, third, fourth term is equal to 9 1 by 2. So fourth term will be a plus 3d in terms of the first term and the common difference. We can write it as a plus 3d, and this is given to be equal to 19 by 2. Now when we know that a is equal to 5, so we simplify to obtain d as 3 by 2. Once we get the common difference as 3 by 2 and we know the first term as 5, we can calculate the second and the third term according to these formulas. So second term would be a plus d for any AP. For any AP with the first term equal to a and the common difference equal to d, you can find the second, third, any term that you want to. So the second term will be a plus d. A is 5 and d is 3 by 2. So we get 5 plus 3 by 2. You simplify it, you will get 13 by 2. I am really sorry. So it's 13 by 2 it will be. There was a calculation mistake. So it will be 13 by 2. A plus 2, d will be 5 plus 2 into 3 by 2. 2 and 2 cancel out and it will be 5 plus 3, that's 8. And we have a plus 3d as 19 by 2. Similarly for the next question, a is minus 4. The second term would be a plus d. Third will be a plus 2d. Then a plus 3d, a plus 4d and a plus 5d. Here we have the first, second, third, fourth, fifth, sixth term as 6. So a plus 5d is given to be equal to 6. Now when we have a plus 5d equal to 6, we substitute the value of a as minus 4 to obtain the value of d. d comes out to be 2. Since d comes out to be 2, we can calculate all the other terms that we need. A plus d will be minus 4 plus 2, which is equal to minus 2. A plus 2d, which is the third term, will be minus 4 plus 2 into 2, that's 0. And we are able to find out all the remaining terms that we need to find out. So there are n number of applications that you can have for the nth term of an AP, and these are just some of the questions that we have encountered so far. Let's visit a few more questions to get the complete understanding of this thing, and then maybe we can move on to the next. So far we have done questions based on a single AP. Now we will be encountering a couple of questions where we have to take two APs simultaneously and solve the question based on the given conditions. So the illustration 12 is about finding the value of n such that the nth terms of two APs are equal. There are two APs that are given. One is this and the second is this. And it is said that their nth terms are equal. Now we have to find the nth value, the value of n for which the nth terms would be equal for the two APs. So we take both the APs one by one. For the first AP, the first term is 63 and the common difference, if you observe, it's 65 minus 63, that's 2. So we write the nth term, which will be a plus n minus 1 into d. If we simplify it, it will be 63 plus 2n minus 2, that is 61 plus 2n. We call this equation 1. For the second AP, the first term would be 3 and the common difference is 10 minus 3, that's 7. So the nth term would be a plus n minus 1 into d. that is 3 plus 7n minus 7, which is 7n minus 4. We call this equation 2. According to question, what do we have according to question? The nth terms are equal, that is 1 equal to 2, which implies 61 plus 2n will be equal to 7n minus 4, which will give us 7n minus 2n equal to 61 plus 4. Therefore 5n equal to 65, and n will be equal to 65 by 5, that is 13. So for n equal to 13, an, that is the 13th term of both the APs, will be equal, and we can also find out the value of that 13th term. We can find an. If we substitute the value of n as 13 here, we can also find the value of the term that is equal, the nth term that is equal. But since we are not asked about that, we'll just leave it at this. Now the next illustration is about two APs have the same common difference, and if the difference between the 100th terms is 100, what will be the difference between their 1000th terms? So here we have the common difference. The common difference is D. The given common difference is D, and it is said that the difference of their 100th term is 100. Let us assume that for the first AP, the first term is A1, and for the second AP, the first term is we can call it B1. This is the first term for each of the given APs. Now 100th term can be written as A1 plus 100 minus 1 into D. For the first AP, the 100th term would be A1 plus 100 minus 1 into D. And for the second one, it will be B1 plus 100 minus 1 into D. So this is effectively A1 plus 99D, and this is effectively B1 plus 99 into D. We have used the same common difference D. So these are the 100 terms of both the APs. It is given that the difference of the 100 term is 100. Let us assume that this is the bigger AP and this is the smaller one. So when we subtract, what do we get? A1 minus B1, because 99D would cancel out, and it is given that the difference of the 100th term is 100. So A1 minus B1 is 100. Now we have to find the difference between their 1000th term. What will be the 1000th term for the first AP? It will be A1 plus 1000 minus 1 into D, that's A1 plus 999D. And for the second AP, it will be B1 plus 1000 minus 1 into D, that is B1 plus 999D. What will be the difference between the 1000 terms of both the APs? You subtract these two. So A1 minus B1, and this 2 will cancel out if we subtract. So the difference of the 1000 term will also be A1 minus B1. And what have we got? A1 minus B1 from the first equation is 100. So the difference of their 1000th terms will also be 100. Let's see this again. What we did was we assumed the two APs to have different first terms, because it's only said that they have the same common difference. Their first terms are not the same. So for the first AP, let A1 be the first term, and for the second AP, let B1 be the first term. The common difference is same for both of them, so it's taken to be D. Now it is given that the difference between their 100th terms is 100. Now for the first AP, what will be the 100th term? It will be the first term A plus n minus 1. N here is 100. So it's A1 plus 100 minus 1 into D, which is the common difference. It comes out to be A1 plus 99D. Similarly, for the second AP, the 100th term will be B1 plus 100 minus 1 into D, which is B1 plus 99 into D. It is given that the difference of these two terms is 100. So when you subtract these two, what do we get? 99D will cancel out, and what we get is just A1 minus B1, assuming that the first AP is the bigger one. We will have the higher numbers. So A1 is a higher number. So A1 minus B1 is equal to 100. This is the first equation. Now we are asked what will be the difference between the thousandth terms. So we write the thousand terms for both the APs. For the first AP, the thousandth term will be A1 plus 1000 minus 1. N is 1000 here. So 1000 minus 1 into D, which is A1 plus 999D. For the second AP, the 1000 term will be B1 plus 1000 minus 1 into D, that's B1 plus 999D. When you subtract this, these two, you will get the difference of the thousandth term. When you subtract, 999D would cancel out, and we will again be left with A1 minus B1. And from the first equation we have calculated already that A1 minus B1 is 100. So here also A1 minus B1 will turn out to be 100. Hence, the difference between the thousandth term for both the APs having same common difference would remain same, and it will remain equal to